Hi there. In this lesson, I'm going to show you how to use the product of power rules to multiply monomials together and then simplify your expression using that rule. So before we get to actually using that rule, I just want to go through and I want to simplify these two little expressions. Now, to do that, I'm just going to think about what do they mean. So this m to the second times m to the third. What does m to the second really mean? Well, it really means m times m. And then we have to multiply that by m to the third. Well, what does m to the third really mean? M to the third really means m times m times m. And now if I look at this, I'll notice that I have 1, 2, 3, 4, 5 m's. So my final answer to a problem like this, when it's simplified, is m to the fifth power. In my next one, I have j to the fifth times j to the seventh. Well, same concept. I look at it and go, well, what does j to the fifth really mean? J to the fifth really means j times j times j times j times j. There's 5 of them. But then we have to multiply it times j to the seventh. Well, what does j to the seventh look like? It looks like 1, 2, 3, 4, 5, 6, and 7 j's. So if I put it all together, all those j's multiplied together, my final answer is going to end up being j to the, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 of them. So j to the 12th power. Now I look at that and go, to me that can be very tedious and time consuming, especially if we had something like x to the 53rd times x to the 72nd. Do you really want to be writing out all those j's? Or m's, or whatever variables they are. So when we look at these two examples, I look at them and go, well, how could I use that original problem to get here without having to do all of this? Hopefully, some of you are recognizing, whether it's the first example or the second example or the combination of both, that, well, I have an exponent of 2 and 3 there, and now it became 5. Here my exponents are 5 and 7. Now they became 12. Oh, we're just adding those exponents together. And that's exactly what we're doing. So that is the product of powers rule. And it just states that for any number a and all integers m and n, what happens is, in the product of powers rule, when we're multiplying two bases, notice the a's are the same in both the first monomial and the second monomial. Bases are the same. Then my answer has the same base as well of a. And then we just have to take those two exponents, the m and n in this case, and add them together. Or if you come back up to our examples, the exponents were 2 and 3, they added together to be 5. The exponents were 5 and 7, they added together to be 12. And that's the product of powers rule. Now I have a few little examples to show us all of this. Start throwing some numbers in there too. So now we have r to the fourth times the negative 12 r to the seventh. I like to break this into pieces. So I'm going to start with the number part, negative 12. There are no other numbers, so my answer is going to have negative 12 in it. And then I'd go to the r's. Well, I have r to the fourth times r to the seventh. Remember, when we multiply bases that are the same, we get to add the exponents. So my base still stays r, but my exponent now is 4 plus 7, which is 11. And I've multiplied my monomials together, and I have a simplified answer. My next one, again, I'm going to start with the numerical part, the 6 and the 5. We're multiplying. 6 times 5 is 30. Next, I'll go to the c's. I like to go in alphabetical order. So here I have c to, remember this is to the first. When there's no exponent there, it's understood to be 1, times c to the fifth. Well, 1 plus 5 is 6, so we end up with c to the sixth power. And then we'll go to the d's. So here I have d to the fifth times d to the second. We get to add those exponents, and we end up with d to the seventh power. And we've simplified our multiplication of monomials. Here another one, just more variables, more exponents. The concept is not going to change any. So again, I'm going to start with my numerical part. So I have the negative 7 times negative 2. That's going to put us at 14. I would then go to the x's, because again, I said I like to be going alphabetical order. So if I have x to the 6th times, remember this is x to the first power, I'm going to have x raised to the 7th power. And then I would go to my y values. So I have y to the 5th times y to the 0. Well, 5 plus 0 is 5, so I'm going to have y to the 5th power. And then last but not least, we will have the z. Now there's only the z here to the 3rd, therefore my final answer is going to have z to the 3rd in it. My next example down here isn't changing any, just another example. Again, I'm going to start with the numbers. So I'm going to start with the 5 times 5. Those are the only two, and 5 times 5 is 25. Next, I would go to the a values. So I see a to the 6th, I see a to the 0. Well, 6 plus 0 is 6, so I have a to the 6th power. I'm going to go to the b's next, so I have b to the 4th, b again to the 1st, and 4 plus 1 is 5, so I have b to the 5th power. Now we go to the c's. So we have c to the 0 times c to the 5th. 0 plus 5 is 5. C to the 5th power. And then last but not least, we have the d's. So d to the 5th times d to the 0. We get to add those exponents again, and we end up with d to the 5th power. And then my last example. Lots of variables, lots of exponents. Let's start off doing it the same way that we've done every other one. So start with any numbers. I have a negative 6 in here, and that's the only one. So then my answer has negative 6. Next I'll go to the e's. So I have e to the 2nd, e to the 1st, and e to the 2nd. So now I get to add three numbers together. The 2, the 1, and the 2. 2 plus 1 plus 2 is 5, so I have e to the 5th power. Next I'll go to the f's. So I have f to the 4th, f to the 1st again there, and f to the 2nd. 4 plus 1 is 5, plus 2 is 7, and I have f to the 7th power. Let's go to the h. So I have h to the 0. Oops, you know what? Let's go with the g's first, because like I said, I like to go in alphabetical order. There are no g's in that first monomial, but I have g to the 1st here. I have g to the 2nd there. 1 plus 2 is 3, so I have g to the 3rd. And then, last but not least, now we'll get to these h's. So we have h to the 0, h to the 2nd, and that's it. So 0 plus 2 is 2, and I have h to the 2nd power. And I have multiplied my monomials together, and I have a simplified answer here in every one of my examples. And that's going to conclude my lesson on the product of powers rule.